Hello guys, let's talk about chemical bonds. These are forces that keep atoms or ions together to form different compounds. And these forces are generally electric in nature, and they mainly come from the attraction between electrons of one atom to the nucleus of another atom. Okay, the repulsion between the electrons or between the atomic nuclei is relatively small. There are three main types of bonds. Ionic, in which case we are going to have the electrostatic attraction between ions, just like in case of sodium chloride when we have an Na plus and chloride Cl minus ion. And we are going to have covalent bonds. This is when between the atoms you share the electrons. An example could be a water molecule. And metallic bonds, in which case we have free electrons that hold the metal atoms together. To some extent, you can think of metallic bonds as the metal atoms would be ions submerged in a sea of electrons, just like it's shown here. So we are going to have a metal atom there, and the electrons are right here in blue, and they can just roam around. So this is kind of a path how an electron would move. But here is a very important question: is a metal made up of atoms or ions? So actually the metals are made up of atoms. Each positive center that you can see right here in orange represents the atom apart from the outer electron, and the outer electrons are still there. They're just kind of floating around, and the rest of the metal atom is within this sea of electrons. Okay, so remember, when we are talking about metallic bonding, we can represent it as ions submerged in a sea of electrons, but in reality the metals are metal atoms. Okay, in order to better understand ionic and covalent bonding, we have to talk about the so-called Lewis dot symbols. Okay, so Gilbert Lewis came up with these symbols in 1916 when he published an article. So in these symbols, we are going to represent the valence electrons of an atom using dots around the symbol of an element. Remember that valence electrons are the electrons on the outermost principal energy level. And the easiest way to figure out how many valence electrons you have is to just know the group number of the element. So here is a periodic table. The lanthanides and actinides are omitted, so I can show you the periodic table in a little bit bigger way in this slide. So here we have group 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. And these are the main groups. This just means that if I have a hydrogen atom, I'm going to have one electron. If I have a beryllium atom, I'm going to have two valence electrons. In boron, 3, in carbon, 4, and so on. So how to draw the Lewis dot structures? Let's start with hydrogen. So hydrogen is going to have one valence electron, so I just simply draw the hydrogen atom and one dot next to it. If I draw lithium and its Lewis dot symbol, then I'm going to have the lithium symbol plus one dot next to it. With beryllium, I'm going to have two dots for the two valence electrons. With boron, it's going to be three dots. For carbon, it's going to be how many? Four dots, right? So these are the Lewis dot symbols, and we can use the periodic table to figure out how many valence electrons do we have. All right, so how is this connected to the ionic and covalent bonding? Well, atoms gain, lose, or share electrons in their valence level in order to achieve a greater stability or lower energy state. Remember, electrons are lazy. They want to be couch potatoes, so they want to be on the lowest energy state possible. How do they do that? They will try to achieve the electronic configuration of the noble gas nearest to them in the periodic table by achieving full valence level of 8 electrons, and this is called the octet rule. Now we know that actually hydrogen and helium is in the first period, right? And it does not have any p electrons. So for hydrogen and helium, we are going to have a duet rule. We only need 2 electrons to have a full valence level. Okay, I hope it makes sense so far. So what happens in ionic bonding? We are going to have one element that is going to give up an electron. This is generally a metal, which has a low ionization energy, and another element going to gain the electron, which is generally going to be a nonmetal with high electron affinity. Think about table salt. So let's try to draw the Lewis dot structures for sodium and chlorine. So I'm just going to put sodium right here plus Cl here. And let's take a look at the periodic table. So we can see that sodium is in group 1a, so it's going to have 1 valence electron. And then chlorine is in group 7a, so it's going to have 7 valence electrons. So now I can just show the valence electrons around the atom. So sodium has only 1. Chlorine has 7, so 1, 2, 3, 4, 5, 6, 7. And in ionic bonding, what happens is one element will give up its electron. So sodium will give up its electron and it's going to give it to chlorine. So we are going to form an Na plus ion. So there is no more valence electrons. And chlorine turned into a chloride ion by taking that electron from sodium. So chlorine is going to have 1, 2, 3, 4, 5, 6, 7, 8 electrons now. So here it had an empty spot, and now sodium's electron is right there. And we know that it has a negative charge. Okay, so this is how ions form, and the attraction between the positively and the negatively charged ions will produce the ionic bond. How about covalent bonding? In this case, atoms will share the electrons to form bonds. So how do we do that? Let's take a look at the H2 molecule. So we know in the periodic table that hydrogen is in group 1a, so it's going to have 1 valence electron. So I'm just going to show hydrogen with 1 valence electron plus another hydrogen atom with another valence electron, and they are going to share those 2 electrons. Okay, so this is actually going to be called a bonding electron pair, bonding electrons, okay, because they form a bond between the 2 atoms. You can also represent the 2 electrons that form one bond with a line, so H, line H. So this is going to be a bond between the 2 hydrogen atoms. Now, how about fluorine? So let's take a look at the periodic table. We can find fluorine in group 7a. So it's going to have 7 valence electrons. So I have to show the 7. 1, 2, 3, 4, 5, 6, 7. Plus, for another fluorine atom, 1, 2, 3, 4, 5, 6, 7. And we can see that we have an empty space here and another empty space there. And so they are going to just share 2 electrons. So I'm going to have the first fluorine atom right here with 1, 2, 3, 4, 5, 6, 7 valence electrons, and the other one right next to it with 1, 2, 3, 4, 5, 6, 7 valence electrons. And then the electrons between the 2 fluorine atoms are going to be, again, the bonding electrons, and the electrons that are not in the bond, but simply in the fluorine atoms, they belong only to the atoms. Those are called lone electron pairs. So lone electrons or lone electron pairs. You can represent the bond between the 2 fluorine atoms not only with 2 electrons, but also using that line between the 2 atoms. So fluorine, line, fluorine. So for this atom, we are going to have 6 electrons, 6 more electrons, 1, 2, 3, 4, 5, 6. And for the other atom, again, 1, 2, 3, 4, 5, 6. So these structures are exactly the same. We simply showed the bonding electron pair as a bond with a line between the two fluorine atoms. Okay, so this was an introduction into bonding. We are going to talk way more about ionic and covalent bonding in upcoming videos, but I hope this made sense and see you in the next video.